Age y is equal to sine of pi times x. Okay, so you guys remember the boxes thing? The boxes? Little box instead of a bigger box and all that routine. So here is, like I a lot of times I'm going to try to picture this like you guys would if you're doing some test or quiz. Like this is number 5 in the whole chain rule section of the notes. But what if this was number 9 on some test later on? It's like completely out of context, right? How would you approach this? How would you know what to do and select the right procedure, right? So the instructions say to find the derivative. That's up above there somewhere. So you're going to be finding a derivative. So you say, cool. Am I going to be using the power rule here? Why not use the power rule? Well, yeah, you got the pi x thing, but it is within the sine. It's not a straightforward power rule at all, is it? Okay. But is it a product rule? Like, is the overall procedure a product rule? Why not? So, say it one more time.
There's nothing being multiplied by sine.
Yeah. Overall, it's just simply sine of something, and there's no times something else. That's a good point. What about the quotient rule? Clearly not that. There's no fraction or division or anything. Nowhere. And so maybe you arrive and you think, well, hey, maybe this is the chain rule, right? You're doing all this mentally, perhaps, or maybe you're writing it out. Is it the chain rule? Well, in order for us to really practically use the chain rule, doesn't this have to be a composite? Mm-hmm. Is it a composite? Is it a function put into another function's input? Yeah. It is. So maybe if you're having any kind of a hard time with something like this, maybe off to the side, you write these down. You say, all right, well, the inside function is this, and the outside function is that. Or if you wanted to say little box, big box, whatever visual you need to help yourself understand what to do. So what would you guys say if this really is composite? What is like the outside bigger function? Sine, yeah. So the outside function is sine of something. And what's the smaller inside function? Pi x. That's right. So pi x has been put into the sine function as its input. So if you're going to be following the chain rule, what you need to do is find the derivative of the bigger box, the outside box. And what's the derivative of sine of something? Cosine of something. And so then, of course, when you open that bigger box, you discover the something that's in there is pi x. So there's that pi x in there. But then according to the chain rule, you have to multiply by the derivative of that little tiny box inside there. So what would be that derivative? Pi. So if you wanted to, you could rewrite this as y prime equals pi cosine of pi x. What do you guys think? Does that seem familiar? Is that a good jumping off point, I hope? Okay. Any questions at all?
If I remember correctly, if there's multiple of them, you do the outside and then you just do the inside is not done at all.
You just kind of work, yeah, exactly. It's untouched.
It's untouched.
Until you get to the next link in the chain.
And then it's untouched, and then you bring it up.
Yeah. Yep. You kind of work your way from the outside gradually to the inside.
But there might be like two functions in the middle that are untouched.
Why don't we do one of those?
Okay.
I like that idea. So what if we did, let's skip ahead to number 7. So number 7, this would be about as complicated as they get for us. They could get more complicated if we really wanted to. But at that point, like if you can do number 7, I feel like you could do more complicated ones. It would just take you more time and space, and I'm not interested in just taking up time and space for no particular reason. So yeah, number 7, y equals sine of tangent of 2x. And this is kind of what Sam was getting at. What if there's like a box within a box, and then that whole thing is within a whole bigger box, right? So here, there's 3 of them. So if I wanted to write this down in terms of boxes, let's say, what's the biggest box? Sine of something. Yep, I'll just put sine of blank. See it? What is the medium-sized box? Tangent of something. Agreed. And what's the little tiny box? 2x. Yep. So small would be 2x. So as we work our way from outside to inside, Sam's idea of as you work your way from outside to inside, do the inside things remain as they are? Yes, until you get to the next link in the chain, until you open that next box. So opening the big box would be doing the derivative of sine. What's the derivative of sine? Cosine. So it's going to be cosine, I'll write y prime equals cosine of something. And what's the input? Tangent of 2x, right? That whole set of inner boxes is still intact. Then I'm going to get to my next link in the chain, and I'm going to open up the medium-sized box. What's the derivative of tangent? Secant squared. Secant squared of 2x in this case. It would be secant squared of 2x. And finally we get to the little tiny box. Derivative of that is 2. So it would be times 2 on the end. Does that make sense? Good deal. Questions? I would. I mean, you could clean it up a little bit. I mean, you could flip the secant squared down and make it cosine squared x or 2x. I don't really see why you would need to do that. I would just leave it just like that. Yeah, Smith.
Sorry, I don't know if you said this yet, but on the AP test, are they going to want us to completely simplify it?
Something like that, they probably would more or less leave it like that, even if it were multiple choice. Multiple choice, you do have to simplify down to be able to match up the right answer with whatever you have. Free response, it's like kind of wide open. In fact, if you wanted to be like a major pain in the butt, like if you let's say the whole separate question, let's say it said find f prime of 9, and the answer was 11. Like let's say that 11 was the correct answer, but instead you wrote this just to be silly. You could, or even worse, you could say this just to be silly, right? Or then you could go that just to be sillier, right? All of which would be correct, and totally a waste of time, but it's funny.
Just don't mess up that one.
But don't mess that up, right? Because then that would be the worst if you got all silly.
Can we do that on your test?
You can. If you do, I will actually read what you wrote. And there was a student, you guys know, you guys never probably knew Matt Horn. Matt Horn was an interesting character. Matt Horn was in BC as a freshman, and he liked to get all tricky, and so he would make me read like these massively long things like that he wrote. And every now and then he'd mess up, and I'd be like, come on, Matt. He'd be like, oh, he thought it was funny. But so, yeah, I will read what you wrote. Please don't do that, though, just in case you lose points for absolutely no good reason. Okay, so in that vein of what you just asked about there, Sam, number 7, let's do number 8. Is it okay? Let's rewrite it a little bit, just so that it's a little more clear what number 8 is. If you see sine cubed of 4t, how could you rewrite that to where maybe it's a little better description of what it is? Parentheses. Yeah, like get the cube kind of on the outside. Yeah, so I think you're right. I think that would help perhaps, especially it would help a lot to see the inside and the outside stuff. So f of t equals parentheses, all this stuff. I think Ryan said it really well. Looks like that. Okay, so when you see this, let's just run through this really quick and I'll let you guys do this. What's the biggest box? Cubed, something cubed. What's the medium-sized box? And what's the tiny box? Okay, so if you can put that together, let's see if you can figure out what f prime of t would be. What rule do you use to differentiate something cubed? Just a regular power rule. So we're going to say f prime equals 3 times whatever that is squared, right? So that's our first link in the chain. We've differentiated using the power rule, but then you start digging into the other boxes. The next box is, like you guys mentioned, sine of something. Do we use the power rule to differentiate sine? We just use the rule for sine, right? And so the derivative of sine is cosine. And we finally get down to that little tiny box, which you guys said was 4t. And technically, you're using a power rule again. What's the derivative of 4t? 4. You can clean that up a little bit. You can multiply the 4 times the 3, you can get 12. But I would give that full credit if you wrote it as is. It's definitely equivalent. Yes, sir.
Okay, so I have a question. Going back to number 7.
Yes, sir.
So if instead of tangent, in the middle, if we had like secant, where the derivative is like secant x times tangent x, how would you write that when you plug in the inside?
Okay, so let's write this out. So you said, what if it was y equals sine of secant of 2x? All right, so we'd go y equals cosine of secant of 2x when you differentiate the big box. Then you differentiate the middle box, which is secant, like you said. So that would be the derivative of secant of whatever times tangent of whatever,
So it's just the secant.
2x times tangent of 2x, right? But then you still got to multiply by the derivative of the little box, so it'd be times 2.
Okay.
Yep,
Sounds
good question. Yeah, 'cause sometimes it's confusing. Does the 2x go in both spots, or
Yeah, that's
it
what I'm
does?
wondering.
It
Okay,
does.
awesome.
Yep. Great question. Let's see. Our class is over in like 1 minute, isn't it? Or it goes till 55. Okay. All right. So I think obviously that's a good stopping point. We're not going to try to do another one in the next 20 seconds or 35 seconds, whatever.
Really? I know.